If you'll turn in your notebook to page 8, colligative properties, we have, in previous videos, we've looked at what colligative properties are. I've shown you an intro to some simple colligative properties, and so now we're going to look at finding the freezing point and boiling point based on the worksheet that I've given you for homework. So we're going to do a couple of these problems together. All right, so let's start with number 1. Number 1 says, if I add 45 grams of sodium chloride to 500 grams of water, what will the melting and boiling points of the resulting solution be? And so just as a recap, we know that the formula we use for change in boiling point and freezing point is delta T equals I times M times K. And so delta T is the change in temperature, I is the Van Hoff factor or the ionization factor, M is the molality or concentration, and then K is the constant. And there are two different constants. There's the constant for freezing, which is 1.86, and the constant for boiling, which is 0.52. Okay, so looking at problem number 1, we're going to go through, we're going to do a little bit of setup work, and then we're going to move. I see that I have sodium chloride. Well, I need to know what the formula for sodium chloride is before I can move any farther. So I know that sodium is Na, and Na's charge is +1. Na +1. Chlorine is Cl, and it is -1, so they are going to cancel and just be NaCl. I also know that they will split up in water, so I can go ahead and write that my Van Hoff factor will be 2. Okay, so let's take this and let's put it to work. We have 45 grams of sodium chloride and 500 grams of water. Well, I don't see anywhere in here a mention of molality, and I know that I need molality in order to solve this problem. So I'm going to find molality first. So I know that M equals moles divided by kilograms. Well, I have 45 grams of NaCl. That's my solute, but I have to turn it into moles first. So 45 grams of NaCl. I know that the mass on the periodic table for NaCl is 58 grams in 1 mole. So 45 divided by 58, 45 divided by 58 is 0.77, so I have 0.77 moles, and I'm going to divide that by kilograms of water. Well, I have 500 grams of water. I can divide 500 grams of water by 1,000 to turn that into kilograms, and that's 0.5 kilograms, so 0.5 kilograms. So 0.77 divided by 0.5 is going to give me 1.54 as my molality. So I'll be able to plug that in for M in my equation. So I know that NaCl is a metal and a nonmetal. It splits into 2 parts, or ionizes into 2 parts in water. So I have a Van Hoff factor of 2 for each of the particles it'll make. I know that my molality is going to be 1.54. I found that by taking moles divided by kilograms after I converted it. So now I just need to plug it into my equation. Now I am going to have to do my equation twice because it asked me for the melting, which is the same thing as freezing, and my boiling points. And since I had 2 different constants, I'm going to have to do the problem 2 times. So let's do the boiling point first. Delta T equals I times M times KB. I is 2 because it's split into 2 particles. My molality is 1.54, and my KB is going to be 0.52 degrees Celsius per M. So when I type that into my calculator, 1.54 times 2 times 0.52, I get 1.6 degrees Celsius. Now this is K for KB, or boiling. I learned that whenever I am boiling water, it's going to go above its normal temperature. Its normal boiling point temperature is 100 degrees. I'm sorry. The normal boiling point is 100 degrees. So if I add that to the change, I get 101.6 degrees Celsius as my boiling point. The problem asked me for the freezing point, or the melting point, as well. So I'm going to have to do the same thing, but this time instead of using 0.52, I'm going to be using 1.186. So I'm going to say delta T equals I times M times KF, and that's going to be 2 times 1.54, and then KF is going to be 1.86. And so 2 times 1.54 times 1.86 is going to be 5.73 degrees Celsius. And I know that's only my delta T, it's only my change. Well, the typical freezing point for water is 0. So 0 minus 5.73 degrees Celsius is going to give me negative 5.73 degrees Celsius for my new freezing point or melting point. It's important to note that the impact on freezing is always greater than the impact for boiling, and so you'll always see a greater change for freezing point than you will for boiling point. Okay, so that's for problem number 1. Let's look at problem number 2. Number 2 says, which solution will have a higher boiling point? A solution containing 105 grams of sucrose, and this is the formula for sucrose, in 500 grams of water, or a solution containing 35 grams of sodium chloride in 500 grams of water. And so in order to do this, I'm going to have to kind of do 2 problems. I'm going to have to look at sucrose, and I'm going to have to look at sodium chloride. Okay, so I have this for sucrose. I know that C, H, and O are all going to be nonmetals, so the Van't Hoff factor for this is going to be 1 because it's not going to break into parts. It's going to be treated as one molecule. On the other side, though, I have sodium chloride. Sodium chloride is Na+1, Cl-1. That's a metal and a nonmetal. So it will have a Van't Hoff factor of 2. And it has a Van't Hoff factor of 2 because it's going to split into 2 parts. Okay, so that gave me my Van't Hoff factor. I'm looking for boiling point. So I have delta T equals I times M times KB. For each side, delta T equals I times M times KB. I know my KB is going to be 0.52. I know that my I for sodium chloride is going to be 2. My I for sucrose is going to be 1 because it didn't ionize. But I need to find my molalities for each one. So I'm going to have to go in and I'm going to have to do a calculation for molality. Alright, so I know that molality is going to be moles divided by kilograms. And I have 105 grams. I'm going to have to turn that into moles. So 105 grams of sucrose, that's C12H22O11. I'm going to have to divide that by its mass on the periodic table. So I'm going to have to do a little bit of calculating there. Okay, so I'm going to do 12, which is the mass on the periodic table for carbon, times 12. 12 times 12, so I'm going to get 144, plus H, which is 1 times 22. So plus 22 gives me 166, and then I have to do O times 11. So O is 16 times 11 plus 166. I get a mass of 342. So I have to take 105 divided by 342 to get the number of moles. The number of moles is 0.31. So I have 0.31 divided by 0.5 kilograms. Now I got the 0.5 because I had 500 grams, divided it by 1,000, and that gave me kilograms. So 0.31 divided by 0.5 is 0.62. So when I put this into my equation, my Van't Hoff factor was 1, my molality was 0.62, and my KB is 0.52. So 0.62 times 1 times 0.52 is a change of 0.322. So it's going to change by 0.322. It'll actually be 100.322 as my new boiling point with sucrose added. Let's see what happens when I add NaCl. Okay, when I add NaCl, I know that my Van't Hoff factor is going to be 2, but I have to find my molality. Well, my problem told me they had 35 grams. So 35 grams of NaCl. I know that NaCl has a mass of 58 grams. So when I take 35 divided by 58, I'm going to get 0.60 as my number of moles. 0.60 moles. I'm going to divide that by 500 grams, which is 0.5 kilograms, because I took 500 divided by 1,000. So 0.60 divided by 0.5 is going to give me a molality of 1.2, so I'm going to put 1.2 times my KB of 0.52. So 1.2 times 0.52 times a Van't Hoff factor of 2, and I get a change of 1.26, and I can see automatically that's going to be greater. Once I add 100 degrees to that, that'll be 101.26. So my sodium chloride solution will have the higher boiling point. That makes sense to me for 2 reasons. First of all, my concentration is higher. My molality here was only 0.62. My molality here was 1.2, so I know it's going to be more concentrated, meaning that I've added more solute. The second reason is I know that my Van't Hoff factor is higher because sodium chloride was an ionic compound, and so it split into more parts than the sucrose did, which was a non-electrolyte, and it didn't split into parts. So this is how you solve freezing point depression, and boiling point elevation problems, all based on the idea of delta T equals I times M times K. Delta T is the change in temperature, I is the Van Hoff factor, how many parts it breaks into, M is the molality, moles per kilogram, and then K is the constant. The constant for freezing and the constant for boiling are located here.